Hi friends, this is Nilesh. Guys, we know that machine learning is an incredible breakthrough in the field of artificial intelligence. It's no doubt that machine learning is the most demand technology in today's market because of the applications that is ranging from self-driving cars to predicting the deadly diseases. And because of this application, it is motivating me to have the presentation on machine learnings. So today, let us explore on basics of machine learning. Let us explore our journey of learning machine learning through the definition first. Guys, it was Arthur Samuel who has given the definition first in 1959. According to him, machine learning is a system that can learn from example through self-improvement and without being explicitly coded. Three factors are of importance here, that it is saying that it is learning from the example, it has a self-learning capability, and it is without being explicitly coded. One thing to remember here is that it is not the case that we do not required to write a program. We definitely write a code, but let us understand why this is saying that without explicitly coded. Let us take an example. Let us think about the traditional programming. We know that in traditional programming, uh, we are feeding the data to the computer, and we are writing some hard code rules to the algorithm. As an algorithm means a rules, bunch of rules. In this case, suppose consider the case of a binary search. In binary search, we are giving the input of sorted arrays to the computer, and computer in the algorithm we will be writing certain rules, fed it to the computer, and computer will give us the predictions. Means it will have elements we will be searching with the help of binary search. One thing to remember here, as there is a fixed set of input, fixed set of rules, and output is also fixed. That means output is fixed means those type of algorithms like binary search, bubble sort, quick sort, insertion sort, those algorithms will have a fixed complexity, that okay, at least with this worst complexity this will work. But there is a big fundamental shift in case of machine learning, because in machine learning we are giving data as well as output to the computer, and this machine, I mean computer model that will be building, it will itself come to with the rules. That means from the mapping of data to the input to the output, computer will itself come with the logic, will itself come with some rules, and we will have those rules. Okay, what is the basic difference here is, we are not it's not the case that we are not writing the rules, but the thing is that for every new need, every new data we will not write the rules, and the algorithm will adapt its response to a new data, and the more response more experience we will be giving to it, the more efficient the algorithm is will become. Let us understand this analogy from the quiz. Consider this quiz. If I say 2 is to 4, 4 is to 16, 6 is to 36, then 8 is to what? Definitely, this kind of behavior that we are trying to teach to machines. That means pattern matching. Here, for machine learning, we'll do the pattern matching. This is another definition of machine learning is here. It is saying that machine learning are the computational methods. Machine learning algorithms are the computational methods that learn information directly from data without relying on a predetermined equation as a model. That means in order to have this answer, machine learning algorithm will look into the pattern here, and for the machine learning algorithm there is not any such predetermined equation, but from the pattern itself it will determine the equation and come with the result. So this is, I think this is sufficient explanation for the difference between the machine learning and the traditional programming. Let us move ahead, and we will discuss some of the technology terminologies for the machine learning. Now guys, let us have some understanding regarding some terms. Algorithm. In traditional programming, algorithm was just a set of instructions. But in machine learning, it is a statistical technique that is used to learn patterns from data and draw significant information from it. That means it's a algorithm will do what algorithm will do. It will learn patterns from data, and it will from that patterns it will derive some information. So this is algorithm, change definition of algorithm. Then what is model? Model is the basic component in machine learning. A model, actually model is a specific representation learned from the data. We are supplying the data and output to the machine, and from that two things, input and output, machine will come up with some specific representation by applying algorithm, what we will be calling it as a hypothesis. Now we have to clear more term like predictor variable, response variable, training data and testing data. Let us clear this for idea from the data set. Suppose we have a typical data set with us. Consider this case of Iris dataset. This is a Iris dataset and is a standard dataset available, easily available on the net. And let us explore on this dataset. Guys, these are the columns. These are also called as a variables, and these are also called as a features. You can see here, consider this case that this is a dataset for classification of any flower. That means sepal length is here, sepal length is given, sepal width is here, petal length is given, petal width is here. And out of these are the instances. These are called the instances. Horizontal rows are called the instances or records or dimensions. So here one can think, we can think that these are the stored rows. It is saying that a particular length, particular flower has a sepal length of 5.1. Sepal width of 3.5, petal length of 1.4, petal width is 5.2, and it is recorded it is a setosa flower. Same style, there are versical flowers, same style, there are virginica flowers. That means out of these 150 rows are for the identification of the which type of flower is this. Means three classes of flowers are there: setosa, versical, and virginica, and these are representing the features of that flower. Here one thing to note that whenever we are doing machine learning, particularly supervised learning, we have to use such data set, and there can be 10 rows in the data set, there can be billions of rows in the data set, there can be 1,000 rows in the data set, and we are applying some two terms here. Let us take right here. One is the training, and another term is a testing. Out of these number of rows, however be the number of rows, nearly 80% to 20% splitting we will be doing, and those major portion we will be utilizing for the training purpose, and lesser portion we will be utilizing for the testing purpose. What does that mean is, suppose this is the 150 rows. Out of 150 rows, suppose 80% rows we will be utilizing for training. That means for the training we will be giving all these columns to the machine, I mean algorithm, along with this label. And for the testing we will be test our result. We will be just be giving these many columns, and we will ask the machine to identify this class label. These terms will be very much clear. We will be typically talking about supervised learning. For time being, just you understand that what type of data set we will require. There has to be a certain quality in the data set, that our data set must have informative and discriminating features. It is saying that informative and discriminating feature is a crucial step for effective algorithms. What does that mean is that now it should be clear that from these particularly features, we are here to know the value of this variable. Suppose these are the 4 variables. Out of those 4 variables, we want the machine to know the value of the 5th variable. actually, let us, you can think this particular analogy with this way. Suppose I am saying y is equal to f of x. What does that means is that here x determines y. That means y is determined by x. And here x is this vector. Generally, we are saying if you are taking a numerical values of this columns or variables, we are saying it is a vector. So you consider this column as x1, this column as x2, this column as x3, this column as x4, and we are calling x is equal to x1, x2, x3, x4, and y is determined by x. That means this class label. Okay, so it is saying that these x should be informative. That means that particular feature should carry some significant information so as to decide the value of the class label. That means they should have a significant contribution for determining the value of class label. And another feature, it is saying that it should be discriminative. Discriminative means that it should be enough, those features should have the enough values so as to discriminate between the rows. For example, let us clear this idea. Suppose there is one, let us say there is some more feature by the name color in this data set, and I am saying that all 50 rows, 150 rows contains the red color. Then this particular information will be of no use to us, because as all the rows contains contains red color, so I will not be able to discriminate how one row is different from the another. So this discriminator feature talks about how one value is different from the another. If such is the information, then it is carrying some meaning in contributing the or deciding the label. Redundant information will not carry any meaning. What does I mean to say? So in short, I am saying that from this, that these variables which are determining this variable, these are called as the predictor variable or independent variable, because their values are independent. And this particular column, we will be calling it as a response variable or independent variable, because its value are determined by this. So I hope now you are clear with that predictor variable or independent variable. Here response variable or independent variable. You are clear with the training data. That means we will be some portion, major portion of the data set we will be using for training purposes, and some remaining portion we will be utilizing for the testing purposes. So I hope these terminologies that we were talking, you are confirmed with algorithm, model, predictor variable, response variable, training data, and testing data. Let us move ahead. Now this particular slide is telling you the overall machine learning approach. This is a very broad approach, and it is showing that there are total four stages in machine learning, but actually each stage require 4 to 5 hours of lectures. We will be dealing with these lectures at length. Let us have overview of it here. First stage is data preparation. Actually, the data that we will be getting for this training is a raw data. That means it may contain many redundant data. There may be any missing values there. There may be outliers there. So much of the time we will be invested in data processing. Uh, uh, any programmer, machine learning programmer, give maximum time in the data preparation, and rest of this portion will require less time as compared to the data pre-processing, because we don't know the quality of the data. We will require to increase the quality of data by involving the discriminating features, dominating features, predominant features, and this way we will prepare the data. Another crucial step is the feature engineering. That means we have to decide. Suppose your data set may contain 150 variables, and all those 150 variables may not be contributing in determining the response variable or dependent variable. So we need to remove such variables And in some cases there may be 200 columns or 200 features. So actually it is called as a curse of dimensionality, and there are many algorithms to solve this issue of curse of dimensionality. And it requires a good experience also to extract the useful features from the data set. Then we will be out from this data and algorithm. We will be building the models. One thing, we have a lot of talk a lot about data. Let us talk about algorithms here. In machine learning, it is said that there is no free lunch theorem. I repeat, there is no free lunch theorem. What does that mean? Is it states that no single algorithm will work well for all tasks. That means we are dealing with machine learning for different type of tasks, and you cannot be sure that okay, this type of algorithm will work nicely for this task, because each task that you will try to solve has its own issues. Therefore you will have to try a lot of algorithms. You have to do a lot of R&D work here to fix which type of algorithm you will be using. And from this data and algorithm you will be building some model, and then we will be doing we will be checking the efficiency of the model thus created. So these are the major steps while doing or solving machine learning problems. Let us move ahead. uh, uh, Let us understand the thing that why we need machine learning as such, and what is the problem that if you are not using machine learning. Guys, you know that nowadays these social media platforms are flooded with much data. Data maybe in terms of images, data maybe in terms of videos, audios, or even a text. Every person wants to uh, write something about his marriage anniversary on the data. Many of them wants to give some videos of their birthdays, or they want to introduce their opinion regarding the politicians. So that is why many social media like Facebook, Twitter, Instagram, YouTube are flooded with this data. Then there is a data in the form of clouds, like public clouds are there, private clouds are there. There is the data. Then web is also a big data source. There is a why this is called as big data. And the day by day new IoT enabled devices are there, which are continuously generating the data. It is said that driverless car are generating the petabytes of data within minutes. And we have a traditional data, traditional data, banking data, finance data, satellite data are there. So these are the various drivers which are generating the data. And as previously so much data 50 years back was not there, and same style there was not so much powerful computing power of machines also. So it's beauty of nowadays that we have a store, we have a lot data with us, and we have good computing powers also. So that is why we, from out of this data, we want the machines to sense the information, machine to go insights of this. That means what exactly I want to say that we want the machines itself to structure, analyze, and draw some useful insights from this data. And this is where machine learning comes into picture. Now, let us talk about decision making. As we are saying that there are huge and tremendous data, we want the machines to take the decisions out of that. Regarding for sales forecasting, regarding the prediction in the downfalls in the stock market, identifying the risk in diseases or some anomalies. And for that, machine learning will be useful. Then another is uncovering patterns and trends in data. That means finding hidden patterns and extracting key insights from the data is the most challenging task, and we want the machine learning to utilize as a catalyst for this purpose. Machine learning allows to dig the data at depth and explore data in a minute. So understanding this huge data and extracting pattern manually will take months for the human beings, but machine can do it through machine learning within a seconds. That is why machine learning is powerful here. And moreover, we want machine learning to utilize for the complex problems, especially in medical science. Machine learning can be utilized for the disease diagnosis. With the help of medical technology that is growing fast, we can able to build 3D models that can predict exact positions of lesions in the brain. And medical diagnosis can use machine learning to train recognizes cancerous tissues. It can be helpful finding the brain tumors and other brain related easily. This machine learning can be equally useful in the fraud detections also. So that means there are the qualities of machine learning which overall are saying these are the factors or the general principles with which we can use machine learning in different domains. So let us see the typical examples or applications domain. Guys, I am here giving you the typical, very typical and very popular applications here, which may be known to you people very well. There will be the separate lecture where I will be telling you the incredible applications of the machine learning. Let us understand the typical applications. We know that Amazon and Netflix, these companies are having their more than 35% of the revenue through recommendations only. That means over 75% of the users select movies based on the Netflix recommendation. How does this Netflix does that is, Netflix machine learning based recommendation learn from the owners itself, or that means users itself, customers itself. Every time you are spending some time while watching a movie or a show, Netflix behind the scene is collecting the data and informing to its algorithm. And it is continuously refreshing. So more the reviewer is watching a particular movie or types of movies, the more up to date the algorithm become and more good recommendation system becomes. Another is face tracking. It is equally known to all of us. The logic behind Facebook's DeepMind face verification system is machine learning and the neural network. DeepMind studies the features in an image, and with the help of that, it is able to tag your friends and families. Another feature is of spam filters. We know that Google hates spams, and it uses machine learning algorithms and natural language processing tasks to analyze emails in real time and classify them as a spam or ham. We know that if Gmail is not able to detect the particular mail as a spam, then if you are taking or recording particular mail as a spam, then machine will itself learning algorithm will understand that okay, this type of mails should be considered as a spam, and it will further identify it as a spam. Then there is a type of imitation learning, or rather we say that observational learning. This observation learning are very well useful in terms of robotics. Today, this is used for robotic industries like construction, agriculture, research, or rescue military, and other type of application. Because you cannot program manually the robot. It's very difficult. Instead, collaborative methods like programming by demonstration are used in conjunction with machine learning to teach programming in the field of robotics. And these assistive robots can be handy. These devices can sense, process sensory information, and perfect actions for people with disabilities and senior citizens. These robots can be helpful for dealing with the surgery, and those can be catalyst to the doctors also. Now we know that we all might have been used Google Translator. We love it. We have a Google, website that can instantly translate more than 100 different human languages by magic. It is even now these technologies are even equally applicable on phones and smart switches. Uh, we have all must have been applied or have been useful this Google Translator, and you can have this technology on smart watches also. So now I have given these applications here so as to increase our motivation regarding the learning the machine learning. guys, we will be taking each stage that we have talked here, each phases of machine learning at length. So for time being, let us stop here. Thank you very much for listening me patiently. Thank you, guys.